how we help them understand their audience, how their audience engages, how to improve that engagement, and monetize them. So, in case you don't know a lot about Quaero, we are at our core data management and analytics company. We deploy our data management and analytics platform in the cloud for our clients. We do so to enable them to use data, analytics, and the insights from the analytics to drive every interaction with their clients, their customers, consumers, audience, whatever you want to call them, but those people who make decisions and buy stuff. This is a representative sampling of our clients, and what you see from this is, while we have a pretty strong presence in the media industry, we aren't just a media company. We don't just serve the media industry. We do have clients in many industries. However, having said that, our biggest growth and one of our biggest focuses is in the media industry. So let's talk about the media industry. There's some pretty significant trends in the media industry that really drive big data for us. For example, and this one kind of blows me away. If you look at the advertising money spent to put ads in front of us as we're consuming media, in the last year, that budget for content that comes to us through the internet, on our tablets, on our smartphones, on our laptops, actually exceeded that was spent for TV. That's huge. That means that there's a shift of content consumption, media consumption, is shifting from TVs to individualized devices. And that means a couple of things. It means, number one, that it's becoming very personalized. People are consuming personal content. It's not the family TV anymore. It's your personal tablet. The other significant thing about that is that it can be tracked. It can be tracked at the device level, what people are consuming, when they're consuming, how they're consuming. That's huge for media companies to know that. Another phenomenon is people aren't just consuming content through the internet on one device. They're doing it on 2 or 3 devices at the same time. So they'll have their tablet out, they'll have their smartphone out, and be watching TV. When you're consuming through 2 devices 2 completely different things, that's called ADD. They call that stacking, because you're actually looking at 2 different things at the same time. And that's happening more and more. When you're consuming on 2 different devices, but it's related, it's accretive, they call that meshing. But all of this multiple screen, multiple device consumption, it generates a lot of data. It's digital data. And it's very valuable to media companies because that allows a media company to understand who's consuming what that mix is across screens, when they're consuming. And they understand it at a personal level. What that means is that they can optimize that engagement, nurture that engagement, and from a monetary point of view, an advertiser will spend a lot more money to advertise impressions to us consuming data when they know that that ad is going to go to a very, very small demographic. What somebody will pay to put an ad on, a sports network site is $10. If they know it's only going to go to males between 25 and 30, go to a certain pattern of navigation through their sports site, and have behaved in a certain way, in a certain geocode, they'll pay a lot more for that. So that now enables media companies to monetize this data. And so big data, where does this all lead to big data? Well, this is all big data, it's all digital data, it's behavioral data. And it's a bit of a cliche, but as the adage goes, actions speak louder than words. This is not inference data. This is exactly what you do at a highly granular level. It's very, very valuable. So let's talk a little bit about our platform. We call it our Quaero Data Management Platform, or QDMP, because you have to have an acronym. And It is a layer on top of other technologies like CDH, Cloudera distribution authority, as well as some other technologies, and we'll dive into that. We've been at this for quite a long time. This has evolved over 10 to 15 years. I'd say in the last 3 years, we've put a lot of investment and focus into it. But just so you understand where the requirements came from, what they are, it'll paint the picture of why we ended up with Cloudera. We needed this platform to be able to manage a comprehensive consumer profile, not just attributes of your email address, your gender, but rich behavioral profiles, exactly what you do. What did you click? What ads were served to you? What transactions did you do? And capturing that data doesn't have any value. We wanted this platform to support behavioral analytics and segmentation, clustering, affinity, those types of models. While the trend is toward digital data, behavioral digital data, we wanted a full 360-degree view, as the cliche goes, of the consumer. So we wanted to include online and offline data, that call center data, or sweepstakes, or survey data. It was important that we were able to identify unique users, whether we know them or not. So what I'm really talking about is the anonymous browser problem. It's by far, when you're browsing content, I forget the stats, it's maybe 90-10 or even less, that most people do this anonymously. But there are still rich behavioral profiles to be gained even from the anonymous data if you can identify that all these records are for person one. We don't know who they are. These are for person two. You can get a lot of value out of that data. Part of our platform is to maintain what we call a digital profile ID just for that purpose. How do you identify unique users, whether they're signed in or not, and track their behavior. That also allows us to convert from an anonymous user to identified user. First, second, third party data, scaling incrementally. That's a huge one, and that's one of the biggest reasons we moved to do. Some of the earlier versions of our platform used Teaser, which is probably a 4-letter word, but one of the main reasons we moved was because we kept underestimating our capacity. We kept filling up the appliance, and every time we needed to upgrade, it was a big event. We had to roll one appliance in, roll another one out, move all the data. It was huge, and it was embarrassing. We had to tell our customers that we had to do this. With Cloudera, just stick another node in, nobody knows any different. If we overestimate it, pull a node out, nobody knows any different. It's really, truly a non-disruptive event. Massive volume, and to integrate multiple technologies. This space is moving so fast from a technology point of view, so we wanted to be able to exploit the best of all the technologies that are out there. So our platform sits on top of CDH, SQL Server, MySQL, and the Teaser, although we use that less and less now. And interestingly, we never had a real requirement for real time. We might, and that's not to say we don't need low latency. But the kind of analytics that we do, big, longitudinal, historical, across true big data analytics, the output of that just doesn't change that much. We're not looking at the last 3 clicks that somebody did. We're looking at long histories of patterns of behavior. And so we certainly want to be fast, but we didn't have a pure real-time requirement. Another thing about our platform and the way we've integrated Cloudera into it is it's not just a big data platform, it's not just an ETL platform, it's a comprehensive customer data management platform. So we've actually based the platform on the subsystems of Kimball, which probably a lot of you folks know about. I'm guessing a lot of people come from data warehousing backgrounds, like we do in my team does. So things like ingestion and conforming data to a common data model, and mastering, denuding data, lineage profiling, we've got that all built in. And again, that runs on top of CDH as well as some other technologies. This is what it looks like from a data flow point of view. We find the central nervous system metaphor is very helpful. This flows left to right. The sensing part of it is the ingestion of data. give us your tired, you're poor, you're hungry. We take data from a variety of places. We have pre-built adapters for common data sources like Omniture or Adobe Analytics data, Google DoubleClick, and a lot of these digital sources that are prevalent, particularly in the industry. We tend to categorize it, so profile data and behavioral data. Profile data goes through traditional master data management type processes, cleansing, parsing, matching, debugging, that sort of stuff, identifying a master individual ID to be persistent. And then the behavioral data goes down the bottom there through Hadoop, Cloudera's distribution of Hadoop, where we get the long-term storage, we get some level of processing. We don't tend to do as much processing down there, and then a lot of aggregating. We then bring all that together into Data Mart. Typically, that's a rich SQL-based data mart because a lot of the consumption applications require a SQL interface. And as I mentioned, one of the reasons we have a layer on top of all this is because things are changing so much. When we started this, Impala didn't really even exist, or it wasn't prevalent. So the low latency SQL query into the data, we needed to move to another technology. Now that Impala is growing and becoming more stable and prevalent, having our layer on top allows us to move those queries that way without a lot of disruption to the applications built on top. What do we do with the data? Analytics. The analytics can either be against an aggregated version here, or they can be kind of the deep analytics into the detailed, granular records that a resident can do. It's from a software stack point of view. That's our layer, which, as you can see, sits on top of Cloudera, as well as SQL Server. I'll show a little bit more how that all integrates in a minute. But this layer where we're implementing those Kimball-like subsystems, and we build stuff on top, specific industry data models, input, output adapters, and then put tools on top of it. Pretty much like I think most people do. This is another architectural diagram, if you will, that highlights the deep integration that we've done with CDH and other technologies. Up here, we've got a SQL server. So it's really, we call it the master workflow server, metastore server. It's a bunch of metadata. It's all about your data, your environment, what kind of processing you want to do. And then it's basically a code generator. So it reads the metadata, it reads incoming data, it matches it up, and then it generates code and dispatches it to the appropriate environment. So if it's going to be, let's say it's tabular data, I hate the word structured data because all data has some structure, but if it's rows and columns, we store it in Hive. So we would generate code that would be optimized, HiveQL, to move and process the data through Hive tables. If it's not structured data, like where the process incorporating comment data from blogs and things like that, then it would just be moved into HDFS. The components of CDH that we've tightly integrated with are the base HDFS file system, MapReduce, Yarn. Then on top of that, we use Oozy for workflow management. We use Scoop we built a synchronization framework on top of Scoop that allows us to do this. It takes back and forth relational databases. Oozy, Scoop, Hive, which is shown up there. And then a lot of the supporting tools, Cloudera Manager, Hue, those supporting tools. But the things that code is directly to integrate with Oozy, Scoop, Hive, and then the basic MapReduce and Yarn. We've been working with CDH for 2.5, 3 years, I guess. And I don't think we were the first, but fairly early. And we learned a few lessons, scar years as the technology evolved. Some of these are fairly obvious, but worth noting. One is, and you can write this down, technologies are good at what they're designed to do, right? And when you assume they're going to do more, you get in trouble. But coming from a data warehousing background, like I do and the team does, you want it to do all the things you want it to do. And so, for example, Hive is not a relational database. It fakes it pretty well. It actually fakes it amazingly well. It makes files look like tables and allows you to run queries against them. And I was impressed when I first got in there and started looking at HiveQL going, well, surely they can't have a form. I'll be damned, they do have that statement. So it fools you, kind of like, hey, it's a relational database. So you bring all of your traditional principles, third normal form, highly normalized databases, and then it doesn't work well. So we had to emotionally get over that and learn that data redundancy is not that bad in the Hadoop world, that we can flatten out tables and have actually the same data in 3 or 4 places, which is still in therapy for, but it actually works better in some cases. Not that you can't join, you can join, but you just got to be careful. If you're going to do a lot of joining, you're going to need to learn about things like map joins. And for overall query performance, things like table partition, bucketing, and then all the myriad of parameters that control that, which we did. It's not a transactional database. There's no update and delete statements at the row level. So if you design a schema, you design a process that really needs those row level deletes, which is very common in data warehousing, you're stuck. You can simulate it with an insert overwrite, but you're basically replacing the table. You're saying, if I want to delete this one record, you say, take everything out, and then put everything back in except that one record. So and we do. I mean, we use that, but you have to use it very carefully. On the flip side, Hive supports development of custom user-defined functions, or UDFs, like a lot of platforms do. Most relational databases do have UDFs. But most of those UDFs and the other platforms, you write the UDFs in the native SQL. So in SQL Server, it's Transact SQL. It's Oracle PL SQL. It just so happens that Java is the common language to write UDFs. And it's bad if you don't have any Java programmers. If you do, you can do some pretty cool stuff. We solve some pretty tricky problems. And I don't know how many people here would say they're pretty geeky, pretty technical. Okay, I won't go into detail. But we avoided a huge table self-join by a clever use of the UDF. We bring all our biases into new technologies. So coming from the data warehousing background, looking at HiveQL, saying, look how rich that HQL is. We assumed that there would be certain things. We had a need to join 2 tables to be able to correlate ranges of IP addresses to behavioral records. And you can only use equals in join conditions, at least in the current version of HiveQL. So we could use between, we could use greater than an equal. So we had to back up, rewind, regroup, and we came up with another UDF solution that was actually very, very pretty good for that. Uzi is a workflow orchestrator. So it's orchestrating this step happens, and this happens, and this step, that happens for the next step. We assume that steps would be able to share data. Whatever happened in one step, created data, all the other ones would be able to take advantage of it. No. So we had to build a framework around that to allow those steps to share data. I assumed that if you took default settings and you didn't optimize your configuration, things would run slower. Well, sometimes they fail. You can run out of memory, run out of map slots, things like that. So you have to be very careful about how you tune these things. And the last 2 are related. Because we love it. We love Cloudera, we love the CDH We've invested a lot in it. It's a significant part of our platform. But it is still in its relatively early stages, right? It's not a 10, 15, 20-year-old technology. It hasn't been around since the 60s. So to really exploit it, you got to learn more of the mechanics. You got to go a couple layers deeper into to know where all the problems are. With that, the support from Cloudera has been critical to our success. So somebody on my team is in communication with Cloudera. It goes up and down, but I'd say average 2 or 3 times a week. Sometimes it's an issue, sometimes it's when's the next release, is this going to be the next release, how do I do that? But because it's still a growing technology, that support is critical. So we talked about media industry, how that generates big data, why that's important, how we integrated Cloudera into our platform to support that industry. Got to end with results. This is an anonymized case study. And I won't go through everything, but you see some pretty good numbers. So this one right here, 250% increase in active registered customers. That's huge for media companies. Media companies will, you've got anonymous users, you've got identified or registered users. They put a dollar figure on every registered user. So that effort to convert an anonymous user into a registered user is huge, and there's a dollar figure associated with it. So a 250% increase in active registered users is a huge benefit. Same thing with content subscription. That means you're bought in, you're loyal, you're getting stuff on a regular basis. And the more of those types of people a company has, the higher ad revenue they can gain from it. These all follow, right? Double the CPM, that's what I was saying, the higher ad revenue. The CPM, it stands for something crazy, but it essentially means how much somebody pays for impressions of their advertisement. So, in summary, the investment in big data for the media companies has been significant. It's yielded measurable monetary results, and it's exciting because there's only going to be more of it. People are only going to consume more and interact more digitally, more data, more value. So we're pretty excited about it. Did you want to take questions now or wait till later?
Dan, for those in the room, while we have Dan's valuable time up there, we thought we'd allow him to take a couple of questions from the audience. So, this gentleman over here.
Yeah, you put out you've got 250 growth, but you also said you now ingest a lot more data. What has been your IT growth? What's your spend in IT growth to match the 250?
Boy, I have to tell you, I don't know all those numbers off the top of my head. I can tell you that the way we interact with clients, we host this in a cloud for us, like a private cloud type deployment. So they're paying us a certain fee and retainer, and then, boy, I don't know. Nars, do you know what the answer to that is?
I don't know the exact number, but I'd say that the growth is a lot less than it would have been if we had not shifted the platform, right? So if we had continued on the trajectory that we were on, the growth in cost would have been significantly higher than if we had not shifted trajectory. What Dan was talking about the old from.
Yeah, and that gets back to, I mean, again, don't tell me, because we used to use Tisa, and that was extremely expensive. So, our margins were lower with that. Now with Hadoop, it's not free. Nothing is free. Open source is not free, but it's a lot less expensive and it's a lot easier to deal with. I mean, the first time we just stuck another node in the cluster, nobody knew it. There's a lot of high five going on.
Okay, other questions? Gentleman in the back.
Yeah, can you talk a little bit about performance and what it was like if this was running in the Tisa, and what the performance is like on the Hadoop cluster, maybe what the size of that cluster looks like? Or?
Yeah, boy, I wish I had more volume metrics right at the tip of my tongue. I can tell you that the Tisa is really great at fast queries. If you got it optimized already and you run queries, it's really fast, which is why I go back here. You'll see we have We still do use Netezza here. Because where we have really high volumes, even of aggregated data, and certain things like Tableau or analytics that just really want highly optimized SQL, it plays out there. However, loading data to Netezza, it's like anything. You have to be very careful. You have to have your
Zone maps.
what is it, your distribution keys. You've got to get a lot of things set up right to get that to load fast. Now, with Hadoop, it's not screaming faster. I mean, it's just the same kind of thing, which is you got to know how to do it to get it to go fast, and you've got to manage that. But with the ability to parallelize all that activity, not only one job, but then multiple jobs at the same time, I mean, it just does that really well. That's what it's designed to do. And like I said, we don't have yet the need to ingest lots of little records in real time, like a transactional database. So, we're ingesting, loading, and then when we get to some of the processes like, conforming data and transforming it, it runs very fast. But it didn't until we got the schema set up right. We started off with a highly normalized schema, lots and lots of tables adjoining one another, and that didn't work very fast. We've flattened some of those out, we've optimized some of the joins, we've added a lot of user-defined functions, and now it performs impressively fast. Kind of a qualitative answer to your quantitative question, but did that? Yeah.
Okay, let's take one more question. This gentleman right here, Paul.
Yes, one of your picture earlier, you showed Jag and you talked about a lot of difficulties you faced.
Yeah.
In terms of, the lessons learned and so forth.
Oh yeah, yeah.
And,
Dave, did you make-
go back a picture. Sorry.
He was just pointing to this slide and saying we talked about lessons learned.
Right, now in that architecture, basically your highway is trying to fulfill the needs of, storing tabular data, right, more of a structured database. Now, did you try to put in a more of a relational database in that architecture, or it's not an option there, or would you speak to that?
Well, we use both. Again, we've built a platform that to some degree hides the complexities underneath. This diagram here, we generate code and then dispatch it. So there are certain processes that we do still run. Our two problem underlying storage technologies now are Hadoop and SQL Server. Some things just run better in SQL Server. Some things we've got legacy code that runs against them. Some of our matching, deduplication, and there's some things that just work really well in relational databases. And where the data isn't so big that it doesn't exceed that, then we configure the system to dispatch it over here. Having said that, this changes, right? Like, for example, I mentioned Impala getting more and more prevalent and more stable. We're also in the middle of doing a proof of concept with another company's technology that does like matching, like record matching, natively on top of the ARM. So where we today would take some of that kind of master data management, matching, and route it over here because the existing tools that we've used for years want that relational structure. We're now looking at things to do that matching here, which is perfect if you think about it. Matching is a great MPP problem. You can split it up and run everything in parallel and bring it back together.
Okay. Any other questions? Dave, one more question. So we're back there.
On the previous slide, you were showing the transactions and various business events that were being ingested. Can you give a sense of the volume of the number and in size?
Yeah, some. I hate that getting, I have no memory, so I can't remember all the numbers. But I do know that for one of our largest media client, these interactions, like clicks type data, we get, I think it's over 500 million a day, something like that. So, we scale. That's one of our biggest scale points right there. Now that's then we add in, and I don't know the numbers on these, but it's pretty big too, the impressions. So if you think about clicking through a site, every time you click, you generate about 10 records. And then at the same time, if you're being presented ads, each one of those gets a record or two. So when you go to a site and go click, if you get presented ads, you probably generate 20 records. And if you think about that, do the math, that gets pretty big. So again, I know it's about $500 million just in the click data, add in the impression data, and probably adds another 70%.
What is the size of that on average?
Boy,
Ballpark?
do you know, I mean, it's,
I think
We saw like just interaction data from one NBC client.
yeah,
It's
one of
like
our
it
small
was
ones.
30 gigabyte. just
Compressed
one
format.
client Interaction data per day.
Per day. Yeah, so on a small end, we do use the same platform for small clients too. The small client, we're ingesting, what was it, 30 gigabytes today of just the click data. That's tiny though.
Yeah, that's real small. So
Per
I'm
day,
just curious,
but that's a compressed
At
format.
what point when you were using that pizza did you realize
When you unzip it,
this
it's
is
going to be
not gonna
returned
handle
again.
the volume, we need some new solution? Like,
Yeah.
what was the tipping point?
You know, it was more the management of the appliance that really pushed us over the edge. Because it's an appliance, right? It's a black box, and we repeatedly estimated we'll be okay. You know, here's $1 million box. We'll be okay for another 18 months. 7 months later, we filled it, you know, and had to go through that event. So I don't even know the answer to the question in the way you framed it, because we had a problem before we ever got there. Do you know what I mean?
Right.
Just being able to, and our cost per terabyte was too high. We were embarrassed by having to keep. Well, remember we said that we'd be okay with that $1 million TF12? Well, no, we're not anymore. We need to control another one.
So it costs more than volume.
Cost and volume from a management point of view, right? It's very, I mean, it's a hard edge. When you fill that bucket, there's nowhere for it to go. You can't run it, whatever it is.
So guys, if you can, go ahead and
Just
give
a
a
quick
quick comment.
addition to that, it was really, it became a client management problem, because we would produce estimates and then we would have to go back and ask for more money, which we didn't want to do. This way, we can price in a much more detailed fashion, and it's all kind of built in, the client, there are no surprises, everybody can plan for it. So, it's more than technology problem, it's a business problem.
Yeah. And then the client will say, oh, I got a new data source that we haven't talked about. Uh-oh, you know, there's a ceiling on what we get estimated. Now we don't. We get in a few more nodes, and $5,000 pop or so.
Okay, great. Dan, thank you so much.
Sure.
Good job.